Okay, hi everyone. In this video, we are going to start off with chapter 11, and chapter 11 is actually an extension from chapter 10, where we actually took a look at the basic angle properties. For example, things like angles along a straight line, things like vertically opposite angles, things like parallel lines. Okay, so we are going to explore a little bit more, and we are going to explore the angle properties of shapes. And the easiest shape for us to explore these angle properties are actually the triangle. Okay, so for a triangle, we have seen in primary school that the sum of the interior angles of a triangle, meaning all the angles in the three corners of the triangle, they all add up to 180 degrees. So for example, if I have an angle A over here, an angle B over here, and one angle C over there, right? This angle C over there. So what does it mean is that the angle A plus angle B plus angle C will be equals to 180 degrees. Okay? Now, so why is this so is because of the alternate angles that we've done before. So for example, if you observe, we can actually draw a line parallel to the base of the triangle over here. And actually, if you can see, we actually have a set of alternate angles over here. So the C will actually come here. Oops. The C will actually come here, right? And then we have another pair over there, the B, right? Do you see, observe over here, the B, right? So for this one over here, the B will come here. So A plus B plus C will actually form 180 degrees, one straight line. Okay? So now, and how whenever we write down, whenever we do um, uh, questions involving angle and geometry, most of the time we have to write down reasons, right? So we have to make use of this habit to present our working clearly by labeling our angles clearly, writing down the working step, and also to write down the reasons behind each of the step. So for the sum of interior angles for a triangle, the abbreviation, the short form is actually this angle sum of a triangle with the symbols. So we can actually write this down as the reason. Okay. Now next, we have one new property that we're going to see in this chapter, which is called the exterior angle of a triangle. So first, what is the exterior angle of a triangle? It is actually this angle outside the triangle. So when you have a triangle and you extend out the length over here, right? This angle outside is called the exterior angle of a triangle. So let me call this angle A, right? And it is equal to the sum of its interior opposite angle. So it is actually equals to these two angles. I'm going to call them B and C. So for this case, angle A is equals to angle B plus angle C, right? The interior opposite angle. Why is this so? Is because when you have 180 minus B and C, it will form this angle over here. And 180 minus A will also be this angle. So when you compare, A is equals to B plus C. Okay, so this is actually a shortcut to what we normally do when we have angles along a straight line when we deal with triangles. So later you can see actually it's actually a shortcut. Alright, so before we proceed, just a quick reminder for all of you to indicate the angle property when you present your answers. So we have a set of basic angle properties where we have adjacent angles on a straight line that we talked about earlier, angles at the point adding up to 360 degrees, vertically opposite angles which are equal. We have the three sets of a set of three properties for angles related to parallel lines, corresponding alternate and interior angles. And in this part, we are looking at angle properties for triangle. So your angle sum of triangle and the exterior angle of a triangle. And last but not least, right, for isosceles triangles, it will be good to at least write down that you are using a property of an isosceles triangle, or that the base angles of the isosceles triangle are the same. So for example, when you have an isosceles triangle, these two lengths are the same, and these two angles at the bottom, we call them the base angles, right? They will be equal as well. So base angles of isosceles triangle. So without further ado, let's go on to practice now 1. So this is a very easy exercise, and I believe you've done so in a lot of times in primary school. So find the value of A in the figure. So all the angles in a triangle add up to 180 degree. So what you can write over here is A is going to be equals to 180 minus 48 minus 90. And because we're in secondary school already, we need to present our working very clearly. So we have to write this reason, right? Especially when it comes to basic angle properties and triangle properties. So we have to write down the angle sum of a triangle or in a triangle, right? So all these add up to 180. So you can take 180 minus 48 minus 90, and you can write down the answer at the next step, which is 42 degrees. Okay, very easy. Okay, so in the figure below for question 2, AC is equals to BC. So calculate ABC. So because AC is equals to BC, right? So the triangle ABC now becomes an isosceles triangle. So when we have an isosceles triangle, these two angles at the bottom, they are going to be equal. So what do is we can take 180 minus off this angle on top, and then we can divide by 2 because they are equal. Okay, so or otherwise you can put x plus 52 is equals to 180, then you can do it like algebra, but usually that takes more time. Okay, so what we can write is first ABC is equals to 180 minus 52 divided by 2, and the reason is because of base angles of isosceles triangle. Oh sorry, without the s. Okay, so it's base angles of an isosceles triangle, or at least you should write down isosceles triangle or property of isosceles triangle. Okay, so then this will be equals to 64 degrees. Okay, so it will be good to double check 64 plus 64 plus 52 indeed adds up to 180 degrees. So this is practice now 1. So let's take a look now at practice now 2, where we are going to look at the new property that we've just learned today, which is the exterior angle of a triangle. So for instance, let's take a look at this y. This angle y is an exterior angle of a triangle because we have a triangle over here, and this y is actually on the outer edge. When we extend this line BC, right, when we extend this line BC over here, right, this angle is the exterior angle. So this exterior angle is going to be equals to 34 plus 75. Okay, so we can write this down where y is equals to 34 plus 75 straight away, and then we have to write down the reason exterior angle of a triangle, and because of that we can add this up to 109 degrees. Okay, now otherwise we can also fall back to our old method in which we can find this angle first. Okay, we can look for this angle first. So what's actually this angle? 180 minus 34 minus 75, which is the angle sum of a triangle. Okay, so 180 minus 34 minus 75, which will give me 71 degrees. And I can, because 71 degrees and y lie on a straight line, so I can write down y is equals to 180 minus 71, and they are adjacent angles on a straight line, and you minus and it will become 109 degrees. So if you compare the blue color working and the purple color working, okay, you can see that the blue color working is indeed a shortcut. So the exterior angle of a triangle is actually a shortcut to a two-step working, which is a shortcut to angle sum in triangle and adjacent angles on a straight line. Okay, so this makes it very easy for us to do certain calculations. Okay, now for B, we are interested to find the value of CED. So how do we find this angle? So where is angle CED? Okay, let me remove this. Okay, angle CED is actually over here, this angle now. Okay, so because we're dealing with triangles, so technically speaking, we can find this angle first, and we can take 180 minus this minus 14 to get CED. However, the shortcut is actually this. If you look at this triangle over here, CDE, right? Y is also the exterior angle of this triangle, and Y can be equals to E, angle at E, and the 14 degrees added up together. So using the exterior angle of a triangle, right, we can write down B is going to be equals to 109 minus 14, right? Why? Because this plus 14 will give you Y. So we can take just 109 minus 14 to get this angle over here. Alright, so this will be, this will be equals to, okay, so this will be equals to, okay, maybe it's too much. This will be equals to 95 degrees. Okay, so alternatively, there's a second method. We can also write down DCE is equals to 180 minus 109, which is to find this angle first. DCE first. Okay, we can write down this, and then we have to write adjacent angles of a straight line equals 71. Then 180 minus 71 minus 14 will give us the final answer, 95. So once again, you can see that the exterior angle of a triangle, right, is actually a shortcut to what we normally do with 2 steps. So if you can see it, feel free to use this new theory, this new property that we've learned. Otherwise, you can safely fall back to adjacent, the straight line angle 180, and also the angle sum in the triangle. Okay, so this is practice now 2 question 1. So now let's take a look at a few more questions over here and to sharpen our applications. So for number 2, right, in the figure below, we have ABC, ADF, and BDE are straight lines. Okay, because they are straight lines, there's many things that we can do. We can make use of like vertically opposite angles and so on and so forth. Okay, so calculate angle CBD. So where's angle CBD? Over here, CBD. So this is the angle that we're interested in. Okay, so as you can see that CBD, it is very conveniently an exterior angle. So the exterior angle is the sum of the interior opposite angle. So 93 plus 41. So CBD is equals to 41 plus 93. Write down the reason exterior angle of triangle is equals to 134. Okay, now for part B, we are looking for the value of B. Okay, so but you have to observe here, this 93 over here, it is not an exterior angle. Why? Because when you extend the triangle like this should be the exterior angle. Or if you were to extend the triangle, if you were to extend the triangle like this, right, this end coming out, this should be the exterior angle. So the 93 is actually not an exterior angle, but we can make use of vertically opposite angles, right? You can see that this one, the 93, is equals to the angle at the opposite. So EDF equals to ADB, then we have to write down vertically opposite angles 93. And once you get this 93 degrees in, so we can take 180 minus 33 minus 93, 33 and 93 to give me 54 degrees. So we can write down angle sum of a triangle, in triangle, off triangle. Okay, so this would be question 2, where there's now a mixture of exterior angle and also angle sum in a triangle. Okay, so let's take a look at the the second last question, practice now 3. So there are many methods for this, because when we have parallel lines, we have many methods to do this, and we have to then now we are interested to calculate angle DAE. So the angle DAE is actually over here, this angle that we want. Okay, so now this being what do you call this, now this being what do you call this, like parallel lines, right? There's many things that we can do. So the first thing that we can look at is based on this 72, you have a corresponding angle 72 over here. You can also do a vertically opposite 72 over here. Okay, at the same time, 147, if you were to observe very closely, 147 is actually the exterior angle. So 147 is actually this angle plus 72. So we can make use of exterior angles to find out our reasons, to find out our answer, sorry. So I will have ADE is equal to 72. Oops. Oh yeah, ADE equals 72. Okay. And DAE is equal to 147 minus 72 because of exterior angle of a triangle. Then we get 105 degrees. Okay. So angle DAE is 105 degrees. Okay. So we write down the 72 first. Then we can write down 147 minus 72. So this plus this is 147. So 147 minus 72 will get me this angle. Okay. Now the second way in which we can do is we can look for angle ADE first, also vertically opposite angles. Then we can make use of the angles along a straight line, like what we do always. So angle AED, which is this angle over here, is going to be 180 minus 147. Okay, 180 minus 147. So this will give me a 33 degrees. Alright, so the 33 degrees will be over here. Then last but not least, I can also write down angle DAE is equals to 180 minus 72 minus 33 because this is the angle sum in this triangle ADE over here. So my final answer is going to be oops, that's my final answer though. Okay, my final answer is going to be 105 degrees. Yeah, 105 degrees. Okay, so here we go. Okay, so this is practice now 3, question 1. And our final question of the day, practice now 3, question number 2. So in the figure, PQ is parallel to RT. Okay, so we have two parallel lines over here. First one here, second one here. Okay, two parallel lines. So we are interested to calculate angle for QST, this angle over here. So as you observe, right, as you can observe, this angle, right, is actually an exterior angle, right? So this is an exterior angle. So it means that it will be good if we can find the size of this angle. Okay, and there's many ways we can do this. There's many ways to find this missing angle QRS over here. We can do this. We can do alternate angles, correct? As long as we find this angle in the first triangle, do the alternate angle to find the second one, and this minus 6, oh no, sorry, this alternate angle and 63 will give me my exterior angle. Now the second way to do this is I can find my interior angles. Do you see? Because we have parallel lines, so these angles, this set of angles over here will add up to 180 degrees. Okay, so there's many methods that you can do. For me, in this question, I'll follow the interior angle method. Okay, so oops. Okay, so I'm going to start off with angle QRS first. So QRS is equals to, okay, so 180 minus of 97 minus of 36 will give me this angle over here. So this angle over here, QRS, is going to be equals to 47 degrees. And because of that, the angle QST is going to be equals to 47 plus 63, right? The sum of 47 plus 63, and this is going to be equals to 110 degrees. Okay, now let's take a look at another alternative method where we can use PQR, right? We can take this triangle over here and we can look for this angle first, PQR. So 180 minus 97 minus 36 would give me this angle 47. Okay, and I can make use of alternate angles 47 over here, right? So alternate angle, oh wait, so QST is equals to 47 plus 63. Oh, sorry, this set of alternate angles. So actually, because these two are parallel lines, right, I can actually look at this set of alternate angles over here. So this alternate angle is going to be this exterior angle. So it's going to be equals to 47 plus 63. So altogether, I will be able to get 110 degrees. Okay, so there's more than one method for us to find final answers whenever we come to geometry and whenever you come to parallel lines and triangle. Okay, so the most important thing that you need to know is you have to be flexible in knowing when to use which property, right? And you need to be familiar with the properties as well. Okay, so one more reminder to everyone is that we have to present our working very, very clearly. Okay, especially when the question asks us to explain why, or to show, or to present with reasons. Okay, so what are the reasons? Let's recap the reasons again. So in chapter 10, we've learned the reasons related to basic angle properties, angle adjacent angles on a straight line, angles at a point. Okay, so the first one adds up to 180, second one adds up to 360, vertically opposite angles are equal. Then three properties for parallel lines, corresponding angles, alternate angles, they are both equal, and interior angles add up to 180 degrees. And in this portion, in chapter 11.1, we settled for angle properties for triangle. The angle sum of a triangle and the exterior angle of a triangle. And for isosceles triangle, we can write down isosceles triangle at least, or we can write down base angles of isosceles triangles. So that's all for the lesson on triangles. Uh, you can use the remaining time to complete the homework in page 4 and page 5. So that's all for the day. Thank you everyone and have a good day ahead. Bye bye.